it's all ChatGPT. I have no idea what's going to happen. If it will work, it will be nice. If it will fail, it will be hilarious. So you're in for a treat either way. Developer productivity, do it yourself with ChatGPT. How I learned to stop worrying and love the AI. So yeah, as you already heard, my name is Baruch Sadogursky. I'm at J Baruch everywhere, more or less. Developer productivity advocate. My goal is to make all of you. By the way, how many of you are developers? Okay, everybody, more or less. Good. Front end, back end. Oh, more back end than front, but surprising. Full stack. All right. Java. Anyone? Okay, a little bit. Okay, cool. You will see why I'm asked about Java particularly. Kotlin. Oh, even better. All right. Okay. Yeah. So developer productivity advocate with the company called Gradle. Anyone heard about Gradle? The build tool, right? We're not going to talk about that at all today. Maybe a little bit. My background, I was a developer very long time ago. And then with JFrog, we pivoted into DevOps a long time ago. And now I come full circle again, working with developers on their developer productivity engineering. Couple of books, DevOps Tools for Java developers and Liquid Software, if you are interested, and just a little bit about myself. So, amazing book by Irene Myers that called The Culture Map. If you work in multicultural environment, which you do, it's not even a question, do yourself and your colleagues a favor, read this book. It's really, really good. It compares different cultures on different scales. This is one of those scales, emotional expressiveness and confrontational. Now, the most emotionally expressive and confrontational people in the world are from Israel and Russia, and I managed to be from both. Living in the States now, it's very a peculiar situation to be in because I managed to offend everybody all the time and don't even feel sorry about it. So yeah, you've been warned. The most important slide is this one. If you go to speaking.jbaruch, you will find there the slides, the video. It's streamed live to YouTube, so the video is already there. You can go there and actually see me and a little bit of yourself, I think. All the links, including Irene Myers' book, everything is there. Now, if you have hard time remembering what is this very complicated URL, it's going to be in the bottom of every slide, together with the hashtags and @jbaruch, which is me, right? So let's get to it. What we're going to ask our large language model, our ChatGPT. So the first question would be, what is developer productivity? What does it mean, and why do we need to invest in it? Why we want to improve it, and then what actually can be improved, right? So that's basically the plan for the next 25 minutes. Now I'm going to switch to actually doing that. So yeah, I started the conversation previously in order to have a link. You know why I needed the link? You don't see it. Okay, it's good that I noticed. Yep, how about now? Now you see it. Perfect. Right, so I started the conversation a couple of minutes ago because I wanted to have a link. Why do we have a link? Because it is in the show notes. So if you go to the show notes, you will actually be able to see all the conversation that we are going to run right now. Okay, so we're ready, and what is DPE? That's what we're going to start. Do I have internet at all? Yeah, perfect. Developer productivity engineering. It's all about optimizing developer workflow from code to deploy. Think faster builds, faster tooling, happier developers. What's next? Let's start with build. Okay, so while we're doing that, quick question. How many of you think that their build is slow? Okay, couple of hands. All right. The rest of you just have a Stockholm syndrome. It is slow, you just don't admit. But you know what? We'll play a game. How many of you have a build which is longer than 10 minutes? Same hands, right? Whoever thinks that it's slow. Longer than 5 minutes. Okay, here is a twist. how many of you have a build with tests that is slower than 5 minutes? Okay, slower than 3 minutes? Slower than a minute? What's going on? You don't build software? None of you? You told me you're developers. Okay, so told you I have zero control over what's going on here, and you now ruined the entire pitch of me bitching about how bad slow builds are, and that you need to run tests, and then you suffer because you wait, but you don't. I don't know what's going on. Never mind. I suffer because my build is slow. It takes an entire minute. I'm going to show you. So this is where is it? Where is it? Where is it? No, I need to exit presentation mode for a second. Right. So basically, this is my build. You can see here, I will going to zoom in when we're going to write code. This is my build, and it's a Java build. This is why I asked you if you work with Java or what's not. And it basically has tons of classes and then tons of tests. Right, so every class have a test that tests whatever it tests. I'm going to run it, and we're going to see how long it takes. Right, so I think okay. Right. So here's my Gradle stuff, and I'm going to run clean build now. Let me just check. Yeah, so this is my build. It's Gradle, so there is nothing too excited here. I have a couple of dependencies. It runs tests. This is pretty much all. So I'm going to run this build, and it's going to take whatever it's going to take. Right, so you told me that you all have short builds. This is taking a minute. The minute is not, it's not very slow, but we're waiting and waiting and waiting. And then you know what, fuck it, I'm not going to wait. I'm going to do context switch. I'm going to the browser, read my emails, chat with ChatGPT while it builds, fine. What does it do to my flow? Not very good, but it is what it is. So let's start with build. Build optimization usually starts with your build tool like Gradle. I use Gradle. You'll want to look at the build scans, parallel execution, and caching. This is interesting. Now, what I want to ask is before we optimize, we actually need to know what to fix. So before we optimize, how do we know what to fix? Okay, you're gonna measure. Use build scans. Okay, build scan sounds interesting. Let's do build scans. Okay, run your Gradle with --scan. Okay. Oh, it's done. Yep, 56 seconds. 56 seconds. But let's now do the same with build scan. What I need to do is edit and then do --scan. This is what it told me to do. Okay, it will run. Wow, that was fast. What happened? I think I didn't disable caching. Did I? No, I did. Oh, because it was build. Now, this is what's called incremental build. Incremental build says, okay, you already compiled it. You already tested it. I'm not going to do it again. So that was very fast. How do we make it to run the entire build again? We're going to do clean build. Clean build. So modify configuration. We need to do scan. And now we're running clean build. Okay, yep, it started and it's going to do the tests again. It will take another minute. Terrible. Context switch. Let's read emails. Okay, I run it with --scan. Anyway, to prevent typing it in the future, I don't want to run --scan every time. I think the scanning is great, and I'm going to show you that what it does, and I want to do the scan all the time. Okay, so this is this. What I just asked is publishing a build can to scan.gradle require accepting Gradle terms of conditions. Yes, but I don't want to do it every time. Okay, I got a link. Let's look what it is. Okay, this is an absolutely free service. Everybody can do it for any JVM build. It can be Gradle, it can be Maven, it can be whatever. And it actually gives us a breakdown on our build. Now, I know that the majority of you have nothing to do with Java or JVM, but you can still have something very similar in your build tool. It might not be out of the box. You might need to measure it yourself, but you can measure it. And what you want to measure is figure out what slows down your build. Out of all our steps, the one that was the most costly was test, which makes sense. Tests take time. We can see what's going on here on the timeline. You can see this is everything else, and this is test. Test takes the majority of time, 54 seconds out of our time. So now we know what to optimize. Yeah, okay. Now, as I promised you, it's going to be hilarious because it doesn't work. Now, those code snippets are bullshit. They don't work. You know why? Because ChatGPT cut time of what it knows is what? September 21. All the stuff that is out there in 2 years, it doesn't know what to do. Will it admit that it doesn't know what to do? Hell no. It's going to hallucinate and invent bullshit like here. I can spend time in typing it in and seeing it falls, but I actually know that it falls, so I can save some time. We don't have a lot. I'll give him a hint. Give it a hint. All right, this is better. Okay, that's the right thing. Now, I will also tell you why it actually, where this comes from. Now, you can see here that I have a plugin enabled. This plugin, it's called Mantium, sorry. And this plugin allows us to add more context to ChatGPT. Now, the usual path to add more context to ChatGPT is through what it's called embeddings. It's not rocket, I mean, everything is rocket science when it comes to AI, but adding embeddings is actually not rocket science. What you need to do, you need a vector database that will parse the context into tokens that large language models understand. You need to feed your content into this embedding database. And then you need to create a plugin for ChatGPT that will add embeddings from this vector database. Now, there are, on those two steps, do vector database and create plugins, there are two things that I don't want to do. Have a vector database and create a plugin. Because I'm not a UI person, I don't understand anything about it. I can do like monkey typing and do the database, but why? There are services out there that can do it for me. Mantium is one of them, and I'm not affiliated, I'm just a happy user. You can actually feed any type of documentation to it. I used PDF of Gradle documentation to feed to it, and it will create ChatGPT plugin for me that will add the context to ChatGPT. So now ChatGPT knows up-to-date information, and it's not limited to the knowledge of September 2021, which is pretty cool. Now, there is another problem. Not anyone can go ahead and create plugin for ChatGPT. There is a huge waiting list. I wasn't that lucky to actually get permission to create plugins. But Mantium has a workaround for that as well. I can use Mantium plugin, log in into my account, and it will use an app that I created, which is basically tons of Gradle and Gradle Enterprise documentation to provide more context. So this is very useful and allows to overcome the September 2021 bummer. Okay, so we are great now. This code actually works. So I need plugin and I need a build scan. I don't need the resolution scan. So I need this part. Where were we? Settings. Here we go. Settings. Let's make it larger here. Okay, so I need plugin and I need here the real version. I think I have the real version somewhere here. No, okay. To search for it. Here we go. What was it? No, that's, oh, okay. Here we go. It's 3:15. Okay, that's cool. 3:15, and then why it doesn't like me? I don't know why it doesn't like me. And then what else do we have here? Build scan. What's why it doesn't work? I told you it's going to be fun because it's going to fail. I didn't expect it to actually fail. Unexpected tokens. Any better now? No. Here we go. Okay. Isn't it what I did? That's Kotlin. Here we go. Maybe it was. All right. Now this works. And the build scan should be within Gradle Enterprise part, right? Yep. Here we go. Yes, now it works. Look at us. What else? Always publish. Here we go. Yep. All right. We're making progress. Perfect. Okay. So this will take care of always publish and all stuff. Great. But our tests are still slow. So now we can tell it. Okay, quick tips. Max parallel forks. You know what? The time is running out much faster than I expected, but I'm happy that I can show you this one feature. Tests take a minute on my local machine. Now you want to see magic. So yeah, it's going to be magic, I promise you. So we're going here and we have tests and we're going to say this, max parallel forks. And I'm going to run it to all my available processors. This is the only change that I do. I didn't do anything else. And it fails before because plugins, didn't I change it? I did. 3:15. Settings, yeah, 3:15. There you go. Okay. Boom, 6 seconds from 60. Now, you know why I want to show you this? Because if you ever need to ask your boss for more powerful computer, like top of the line Mac, now you have an argument. You're going to tell them, hey, do you want me to be productive? I need this Mac because look what happened. Now, this is really good stuff. But you know what? How about I don't run tests at all instead of running tests fast? What I want to say, Okay, test impact analysis. What is test impact analysis? This is another interesting feature. Now, what it does is selects which tests need to be run. Now, there are two approaches to it. The first is your classical, okay, we have modules, and if I didn't touch this module, and whatever I touched is not dependent on this module, I don't need to run tests, which is pretty cool, works out of the box. Most of the builds know how to do it. But I think I want to ask something else. How about using artificial intelligence and machine learning in order to know which tests are expected to fail, even if the modular analysis is not good enough? So let me show you something. Again, developer productivity. So this is, how many of you know about Spring Framework? Yeah, okay, the majority of you. Spring Framework is, I think, the single most important framework in Java and JVM world, and it has like everybody use it. Now, this is their Gradle Enterprise instance. Predictive test selection does exactly what I told you before. It monitors the builds, and then it says, okay, those types of changes in those classes probably won't break those tests. So when those changes happen, we don't need to run those tests, even if they are in the same module. And let's see how smart the model is. 98.7% of failures predicted, over 98% in tests predicted. So this is test tasks, and this is like generally tests. So it missed 4 out of the base of 35,000. That's pretty solid. The question is how much time it actually saves. Now, over the last 7 days, it saves 7 days. Obviously, there is much more parallel builds that running than one, so this is why it actually works. But it actually saves almost 30% of build time for the entire Spring Framework team. Now, this is very, very impressive, but we still have this, red. Now, does it make you uncomfortable? It should, because, you know, this is production tests. The entire world use Spring Framework. What's going on? Are there tests which weren't tested? The answer is yes, but also no. Yes, because this is for local tests. This is how much time it saves for the developers when they run those tests on their machines. Now, we have more quality gates. We have continuous integration. Do we turn on predictive test selection and continuous integration? Hell no. Continuous integration, this is where we want all the tests to be run all the time. But on local machine, the trade-off of 2% false positives and saving this much work, definitely worth it. So what else did I want to show you in the very, very limited time that we have left? So obviously, ChatGPT wants me to set it up. I want to do something else. Another feature that almost every build tool has is the build cache. Now you can see that Gradle, as others, have two levels of caching. It has the local cache and it has the remote cache. Now, local cache will mean that my build won't even try to run the tasks which are cached. Now, you saw it when I ran the build previously and it was blazing fast. That was not caching. That was Gradle thinking that the tasks are up to date. They didn't change. How it's different from caching? Caching actually caches the inputs of the task. Let's say we're talking about compile. It will cache the sources that needs to be compiled, and it will cache the output of the task. In my case of Java, it will be the class files. Now the logic is very simple. If the hash of the inputs didn't change, we don't need to bother with compiling. We can pull from the cache the compiled classes using this hash. It will let me run local builds and use local cache even when I run clean build. Again, I can plug it in and you can see it working, but I have 3 minutes left. Wow, half an hour is brutal. Remote cache is even cooler. It actually uses an HTTP server, and you can spin it up yourself, or you can use one out of the box to keep those caches in the server. What it will do is, obviously, your colleagues will be able to use your cache. So when you build something, other people won't have to. And there is one nice side effect. When you come Monday morning to work, and especially if you work with your distributed teams, the first build will always be slow, right? You know that from experience. Why? Because your cache is not up to date. A lot of things changed. But if you enable remote caching for your CI, every CI build will populate the cache for your entire team. So you won't need to wait for almost any build ever, because your CI is constantly building and gives you all the caching out of the box. This is very, very powerful as well. So we spoke about parallelization, we spoke about caching. One more thing, parallelization in the cloud. The same idea as with caching. If we can do it locally, we can do it in the cloud. Your tests can be even faster if you ask the cloud to run them for you. This is another developer productivity engineering improvement that you can get out of the box. So you will spin virtual machines, you will run your tests on them, and then you will get the results. You probably already do it for your CI. This is called CI fan-out. There are a lot of tools that do that. All of them are particular for CI. But you can always do it for your local tests and make your builds faster. So, geez, we spoke about that. And answers that some of them we got, some of them we didn't have time. So developer productivity engineering helps us improving our overall developer experience. The build is the good place to start because in the build there are a lot of low-hanging fruits, as I showed you. It's not only Gradle, Maven, SBT, Bazel, any other build, not only on JVM, every build can be improved. And it's not only the build. Improving the entire cycle is important and worth investing. What else can be improved? Stuff like using better IDE and using linters and using stuff like test containers to improve tests and what's not. In the build, what we can do, caching local and remote, parallel testing local and remote, predictive test selection that I showed you earlier. Another feature we didn't have even time to mention is flaky tests. Who loves flaky tests? No one ever you like flaky tests, good man. But yeah, no, you don't. You can fight flaky tests easily. All you need to do is make sure that you run the same tests if they fail just a couple of times more. And if you see that there are tests that sometimes fail and sometimes pass, you can diagnose them. First of all, you can quarantine them. You can say, disable those tests because they ruined my life. In some point of time, you can revisit them, see what they're taking, and actually do something about it. So do that. Invest in fighting flaky tests. And of course, degradations. You sped up your build. It's now blazing fast. What is going to happen in 2 months? It will be slow again because changes are creeping up and they ruining your developer experience. Don't do that. What you can do today, parallel local caching, remote caching, it will require some work, but you can still do it, and build scans, whether it's in a Gradle platform or anywhere else. Yeah, and you can also win prizes. If you go to speaking.jbaruch, there are speed challenge that you can run. What company should pay for? Gradle Enterprise or similar platform that will make your builds even faster. Okay, something that I already mentioned, the secret sauce of ChatGPT is the ChatGPT plugins. To my knowledge, of September 2021 can be overcome by feeding ChatGPT with your own custom knowledge base, embedding plugins, populate vector database, create ChatGPT embeddings plugin, or use third-party service like Mantium. So with that, you can go to this URL or scan this QR code. You will find the speed challenge over there. You speed up your build, you win prizes. Isn't it sweet? And there is a developer productivity engineering handbooks over there. There is also developer productivity engineering summit that is actually happening day after tomorrow. It's very convenient. This conference ends, the next conference starts. There is one caveat. It's in San Francisco. So I'm going there tomorrow. If you want to join me, I can take you with me. If not, the videos will be out soon, so you'll be able to watch them. And with that, thank you very much. Baruch, Shift Your World, Infobip Shift, and the most important URL, as I already mentioned. Thank you.